Learning Outcomes 6.3. Relate linear and logarithmic representations of frequency response. We talked about ideal filters having a stop value of 0 and a pass value of 1. And we talked about ideal filters and real filters. But these pictures were all linear representations, linear in frequency, linear in amplitude. You also are familiar with Bode plots. Bode plots are logarithmic in frequency and logarithmic in magnitude. While this looks linear because we draw on semi-log paper, this is in values of decibels, which is a logarithmic scale. So how do we convert between them? Well, our cutoff frequency is just some frequency we will draw on our plot. 0 as a frequency is a very, very small frequency. And maybe 1 isn't small, so maybe we need to have semi-log paper that is starting off at 0.1 instead of 1, or we can draw more and more decades. But ultimately, we're never going to reach all the way to 0. The frequency omega equals 0 is over here to the left by an infinite amount. But that's okay, because we can predict what's happening there. We can get very close to 0. Negative cutoff frequency, and everything in the negative, we cannot draw in log paper. So this whole area from slightly positive of 0 to negative infinity we don't draw. But we know that it's there because of symmetry and being able to interpolate what we think is going to be there really close to 0. What about magnitudes? We want magnitudes of 0 for block and 1 for pass. How are those represented in terms of decibels? What is 20 log base 10 of 1? It's 0. How about for our stop magnitude, 0? What is 20 log base 10 of 0? Negative infinity. So where are these in our magnitude? Well, here's our 0, and we're going to have 0 at frequencies lower than omega c. What about when we're greater than omega c? We want to have 0, which is all the way down at negative infinity decibels, which we don't have drawn on our plot, but we know it's down there. It's really far down. So if we take this into consideration, that's how we draw our filters in a Bode plot. And for instance, we will transition gradually from pass down to block, and the steeper that our slope is, the faster we make that transition. And we generally say that if we are 6 dB below our maximum, that's where we say that we've started to stop or block, because enough of our signal is attenuated.